So let's start then. So I guess we've all been promised very nice things about Java 21 and Project Loom and virtual threads and everything, right? So this is like a tiny demo everyone is showing, myself included, right? So you have these, let's say you have just incoming requests, right? And you want to handle them using threads, good old regular threads, like platform threads and whatnot, and we give it a spin, we try to run it. Let's say every task like takes 10 seconds, right? And I try to run it on my machine, which is like a 4-year-old PC, and oopsies, it doesn't work. Why? Because I'm not able to spawn that many threads. Of course, I could like tune it a little bit, make the start threads a little later, but I would just postpone the inevitable, right? The crashing the wall again. That's why we can't have this thread per request approach and whatnot, because it's out of memory error, because operating system says like no more threads for you, because these threads in Java are one-to-one with operating system threads, and so on and so on. So everyone is like, yeah, super excited. Now I can show you how to do it like in no time. So instead of just using platform threads like these, you can go for virtual threads. So you can just go thread or virtual and unstart it. I could already start it, but I want to start it here manually, right? Sort of. And instead of going 40,000 threads, I can try going for, well, not 100. Okay, let's go for 1 million. I mean, YOLO. Right, let's go for 1 million virtual threads, and let's see if my machine is capable of creating 1 million virtual threads. It's doing something apparently. Maybe it's just emulating this working for 10 seconds, right? And so let's wait, I don't know, 10, 9. Come on, you're spoiling my demo. Bloody machine. It's always like this, right? You want to run something. Okay, no, actually, this is how much it takes. Okay, it takes around 20 seconds. So 10 seconds is like they say, it's kind of like reserved or expected time span, plus 10 seconds is is for printing this, switching the threads and everything. So it's the overhead. But I would say, and you will agree, it's pretty decent. I mean, okay, there's 10 seconds overhead, but the guy was able to run like 1 million virtual threads, okay? Yeah, the question is that really true? Did I really run 1 million virtual threads? And it's because, I mean, there's a hint for you, okay? This is a hint. I'm not really working, I'm emulating that I'm working. And the whole emulation is this, right? That I go for the sneaky sleep, right? And I just say thread sleep. So these threads aren't doing anything, they're just sleeping, okay? And virtual threads are great in doing two things, sleeping and waiting. Okay, this is where they excel. But the moment you start doing something more perhaps sophisticated, let's say, and instead of just going for sneaky sleep, I'm going to go for some really hard work. And hard work means that you can see I'm just dividing like some numbers, the modulo and whatnot here, and it's actual like CPU bound work, right? It's intense work. So now if I try to run this demo again, as you can see, I'm still able to create 1 million virtual threads, but then I haven't really tried it. Sorry, 1 million, right? What did I say? Okay, 1 million. I don't know how long this demo would take, right? And I could annoy you with more dad jokes, which are really bad, right? But maybe that's not the point of this presentation. You see, virtual threads aren't any faster than, or maybe they are in some scenarios when it comes to switching, because they have like smaller stack traces and whatnot, right? But then you go to these talks, right? People are excited, like, yeah, virtual threads, and then you switch for virtual threads in your application, and suddenly, somehow, it doesn't work. The application is not working faster. Why? Because you are misusing virtual threads, or maybe you are using them correctly, because you haven't been in this industry for so long, just not to create some job safety, right? So, like, you don't want to migrate again. It was in Java 5, we just migrated to generics, okay? In Java 8, they told us to go like streams and lambdas. And now it's again like migrating. Come on, I've been migrating 2 times in my life. Isn't it enough? Why I just didn't prove them that virtual threads are useless, right? I just use some clever techniques you're about to learn today to just butcher virtual threads, to tell everyone they're not working, they're not worthy. You just keep doing these mistakes, of course, secretly, so nobody sees, and your job is secured, okay? And you don't care about this thing. See, it's still there, and my fun started growing, because now it's actually doing this CPU-intensive job. It's not sleeping, right? Okay, so this is how you can butcher virtual threads like to begin with. So welcome to this talk, Bachelor Virtual Threads Like a Pro. I am Piotr Przybyl. You can find me on social media if you fancy to follow me. I claim to be software gardener. I'm also test containers community champion. I give trainings from time to time. If you're more into reading, not watching, or attending talks, you can go to my blog page, softwaregarden.dev. And just as J4 has been doing it for 20 years, I've been programming in Java for 20 years, only that I didn't have a break for a pandemic. A little warning, everyone is a human being. I'm a human being just as you are. I'm able to make mistakes, okay? So just, especially if you're watching this on YouTube, right, don't try talking heads, okay? Just try to keep like a little bit reason, maybe verify on your own, try different sources, whatnot, okay? It's a human thing to make mistakes. Virtual threads are official now in Java 21, but structured concurrency and scope values are still preview features, which means you have to go for this -- enable preview in your IDEs if you want to try them out, okay? In Java 21, if you want to understand how it works and whatnot, I recommend watching this part of my presentation when I explain it to the bone, like to the class file and so on. Right, so concurrency, right? This is the thing that changed in Java 21. Sorry, when is this presentation supposed to end? Really, I forgot. It's 50 minutes? Yeah, 50 minutes, so it's 11:25, right? If I'm not mistaken. Yes, cool. Okay, so the issue is, back in the day, we were forking our processes. If our application, our system had to do like two or three things, and we had like more than one CPU, we could easily fork processes, right? Or well, easily, that's the thing. It wasn't easy. Especially communication, like inter-process communication was kind of like difficult. You know, this shared memory, we had to like have the semaphores apart from the memory and whatnot, right? So it was slow, it was costly, it was really pain in the bottom. So we went for the concept of threads. And for a moment, it was like a really good idea and like a fresh breeze, because now I have this like inter-process approach, sort of, and I don't have to pay the penalties or like inter-process communication, because it was like the same memory and everything. It was nice. And we like realized that there is this request per thread approach, okay? And until we had like 20 or 30 requests again in a given time span, okay, just like I can have with this machine, it was all okay. But then, once we started to have more and more and more requests, apparently it's no longer possible. So we had to abandon this thread per request approach. Reactive was born, and so the story went, right? As you've seen, there's this limited number, right? And okay, who can debug reactive stack without IDE? Exactly. I'm not in this room as well. I know for sure. I know two people who have this laser vision and can do that without IDE, right? Extremely brilliant folks, like Java champions and whatnot, masters of. Actually, sorry, three. Three. But else than that, it always requires some tooling, understanding, scratching the head, like swearing, like bumping your head against the wall and whatnot, right? And also in Java, we don't have any async await as our JavaScript friends have, right? Because we have like then wait for this like completable future, or right? So there they come, virtual threads, part of the project Loom, and people are asking this question: is this the biggest change since Lambda? And basically, there are two parties. One group says, yes, it's the biggest change since introduction of Lambda. And the other group says, no, it's even bigger. Right? So it's up to you to answer this question. I don't know this. Yeah, it requires some thinking, some tinkering and whatnot. So what they are part of this, or they are delivered as standard feature as this JEP 444, but we also have structured concurrency as this JEP in preview, in first preview feature after incubating twice, and we have scope values, a new kit in the blog, also in Java 21. All right, so the cornerstone of all these changes around concurrency in Java are virtual threads. The whole idea is like, who knows how to use threads, more or less? Executor services, factory, exactly. See, almost everyone. I think I can assume everyone raised their hand, right? You can't be like a true Java developer if you don't like at least like have like a rough idea how threads are working. Okay, there are still some quirks like these dining philosophers and whatnot, right? But in general, we get this idea. So the whole point was not to reinvent something else, like fibers or whatever name there was, but just stick to this model because people like educated over like more than 2 decades. We have books, we have everything, we have tutorials, we have understanding. So just to keep it, right? And they are cheap to start. They are cheaper to start than platform threads because they happen only in a Java process. The operating system is unaware of this. Okay, so it doesn't require calling operating stuff. So if you go for any performance talk, you see that when it requires calling operating stuff in async profiler, is this orange or brownish color, and then basically it means here comes the trouble, right? But they are carried in by platform or OS threads under the hood in a way, and they unmount carry threads when they are sleeping or general waiting, for example, I/O, like doing file system operations, calling third-party systems like be that databases, message brokers, microservices, what have you, right? And they're always daemons, and they always act with with this normal priority. Okay, so if you have only virtual threads, your system, your Java application will stop. And this is how they work, more or less. The way I see them is that they might be seen as the passengers of taxis. Okay, so the problem with thread per request is that we don't have enough resources, just like we don't have enough space for all the cars in the city. So the idea is, instead of everyone having just a car, maybe whenever you need in a city to get from point A to point B, you just call a taxi or you call an Uber. The car shows up, you as a virtual thread get into that taxi, which is a platform carrier thread, okay, and it takes you from point A to point B, and then you unmount the taxi, right? And you as a virtual thread are doing something else, which is waiting. So you're attending a talk, you're having lovely dinner with your friends, you're watching a movie, I don't know. And then, right, when you need to when you're done with this I/O stuff, with this waiting stuff, you call taxi again, taxi shows up, you mount it, right, and it takes you back, or it takes you like to another destination, and so the story goes, right? It's like we could go with car sharing and so on. The idea is there are less hardware resources needed to accommodate transportation needs of certain group of passengers, or if we happen to have or keep the same streets and the same number of cars, we just turn them into shared cars, right, autonomous or not, then we are able to have significantly more passengers transported using the same pool of resources, okay? That's the whole idea. And there is no magic switch to turn the regular threads you have in your application into virtual threads, okay? You just have to go and visit your source code and change these places. So you can start like this with thread or virtual and then go start. And this builder is very nice if you need to like change set like a name or whatever, right? If you fancy just to start it instantly, you can go like this, start virtual thread and give it a lambda or just a runnable. And if you need executors, you go like this. And this is important part is this, like thread per task, right? So whenever you have a new task, you create a new thread in this. They are not pulled or anything like this or reused. If you need a thread factory, you go for thread or virtual factory, right? And of course, like, it might be that you are using or relying or standing on the shoulder of this giant called a framework, right? So you might have Spring, you might have Quarkus, you might have Micronaut and whatnot. And then they might be in a control of these virtual threads. So then, for example, you can go with Quarkus run on virtual thread, right? And in Spring Boot 3.2, we'll be able to go for Spring. So it's not it's just a property. Spring threads virtual enabled equals true. And then whenever Spring or Quarkus thing, it makes sense to run this thing on a virtual thread, and virtual thread is available, it will be run on a virtual thread, right? So this is the switch. But there is no the capital D, dash D or dash XX to like switch to virtual threads, okay? It's not there. There is no such option, and I think there's a very nice reason for this, because then everyone would be butchering virtual threads, really, myself included. And there's this one thing. Virtual threads won't squeeze magically more juice out of your CPU, okay? Your application will scale better, just as with taxis, we can scale better the number of passengers, but the passengers aren't traveling faster from point A to point B, assuming the taxi driver isn't crazy and is not speeding, okay? But just by switching from like a regular car to taxi car or an Uber, you're not getting faster from point A to point B, okay? Because there's the same traffic conditions, there are the same cars, the same speed limits, the same laws that need to be obeyed and everything. So just because you switch to virtual threads, if you have CPU intensive computation, it won't be any faster. It won't add like a few gigahertz to your CPU, okay? Or a few cores. It's not going to happen, right? Keep it in mind. So it's just whenever you have to wait for I/O, then virtual threads are going to shine. Yeah, just remember that our application will scale better. So instead, for example, for going like yet another instance on cloud, maybe you can switch to virtual threads if your application does a lot of I/O, and then you will squeeze more of your CPU in this regard that it won't be wasted when waiting, okay? But maybe this is something we want to do, just to secure our jobs, just to waste it, just to prove it's useless. We still have to keep to Java, working with Java 7, right? Because it's very nice, it doesn't have streams, and it still accommodates Kotlin. So what else do we need, right? So what not to do with virtual threads? We don't reuse them. They are so fast, they are so cheap to start, we just don't reuse them. Hence the name of this executor, new virtual thread per task, okay? We don't pull them, therefore, right? So we need a different mechanism to handle control flow or back pressure or whatever other like commercially available name there is for this, okay? Just we have to keep it in mind. And another thing we don't do is we don't pin virtual threads. So if we stick to this metaphor, right? Let's say you're going to rob a bank. Just hypothetically, you're good people. We're not robbing banks, okay? It's them robbing us, but that's another story. So let's assume just we're going to rob a bank, right? So you call a taxi, right? The taxi driver takes you to the bank, and here we are at the bank, right? And then you pull the mask down, right? And you tell the driver, stay here and keep the engine running, okay? I will pay for this, okay? Then you go to rob the bank, right? You do business, everybody give me the money, please, and so on. You get with these bags or bars of gold, whatever, right? Or diamond. No, we're not in Antwerpen. Okay. And then you get back in a taxi, and he or she drives you back home, and you have to pay not only for the ride, but also for the time you spent there, where the engine was running, okay? Who does it except like cheap Hollywood movies when they're robbing a bank? Exactly, because it doesn't make sense in real life. Nobody tells the taxi driver, okay, we may say, stay here, but we never say, keep the engine running, okay? And this is actually like pinning virtual threads. And how does it happen? When you call this I/O operation inside synchronized block, okay? And this can also like be like native operation. So there's synchronized block or synchronized method, and inside you call this operation, which normally would make a virtual thread like release the current thread, like, thank you very much, taxi, go, I'll call you or call somebody else, right? But instead we just say, stay here and keep the engine running, and it's called pinning. Okay, and how can you detect that it's like somebody else is looking for keeping their job endlessly? Okay, you can check it in two ways. You can go for trace pin threads full. This would like print you a nice stack trace, or we can go and watch for Java thread recorder events if there were any events emitted. If I'm not mistaken, virtual thread is considered to be pinned if this blocking I/O takes more than 20 milliseconds inside this synchronized block, right? Okay, and how can we detect this? Let's say I have this microservice, right? And inside this microservice, I have something. I have just functionality. In my case, I have this HTTP client, okay? Something that's doing I/O. It doesn't really matter what that thing is, but this is my example. And your example should be like similar in a way. And then what it's doing, it's basically calling and somewhere to the internet, right? Like an URL, and it's just getting back the response and checking how many bytes are there in this response. And that's it. That's what it's doing. So in my experiment, I'm basically calling I'm deploying index HTML file to Nginx server, and then I just go there and check how many bytes are there, right? And if I make this direct call, and both are running in my CI infrastructure on my laptop, or I've already been to these talks about test containers, right? Then they are still like happen locally, and I don't have this 20 milliseconds to go back there and back again. Okay, so the idea is to have these conditions. Okay, so I can use this wonderful piece of technology called toxiproxy, which allows me to creating intoxicated networks programmatically, right? So I can say instead of going directly like previously, I can take this little detour, and going by this toxiproxy will make me like have like more or less like half a second delay, right? So there's like this latency is half a second plus minus 50 milliseconds jitter, just not to have like always half a second, right? A little bit chaos engineering. Someone expected chaos. Who was that? Was that you? Okay. See, you predicted very well. I have jealous for you. There you go. Yeah, so we have some chaos. This is chaos engineering, right? And this is this chaos monkey. It's called toxiproxy, and we're going to create our application, pack it into test container, right? We are going to create this test container with Nginx, and in between we're going to have toxiproxy also running in test containers, right? So how can we do that? I happen to have this application. Let me go with here. What is it like? It's come on, quickly. Where is it? Come out. Yes, I have this application. See, this is my application. I have these arguments, right? And if there are some arguments, I basically create this immutable HTTP client, right? I create a request, which is also immutable, and I'm going to send it 20 times to this URL that I'm specified, right? Basically, it's like as stupid as it is, just to give you an example how you can test it, right? And then I maven it, or Gradle it. I have the artifact, and my test is where's my test? This is my test. Yes, as you can see, like little spoiler alert, it seems not to be passing, right? So I have this index.html file, and I copy this it from resources, so it should be here. Right, I copy it to the Nginx container I'm creating or declaring here, and then I have this toxiproxy container which I declare here. Then I start them both at the same time, because not to waste time, okay? And then I have this proxy, and I say this is the chaos monkey here with this more or less half a second delay. And yes, and then I create, so I have this thing set up, and then I create my, I pack into this container my application. Basically, I start this application, and I tell it, because it's it's actually no longer needed, it no longer needs enable preview in Java 21. And then I say trace pin threads, right? And this is the URI from the container, which comes from toxiproxy, as you can see. So basically this guy knows it has to call somewhere here, but doesn't know it's toxiproxy and so on, right? And then when I run this test, it should fail. Let's see if it fails. Very nice. It's not even integration test. It's some call it like a golden master test or something like this. I don't actually care about the name as long as it gets me covered, right? So I have confidence this thing is passing the test or not. I'm happy with this. As you can see, the test is not passing. Let's see why it's not passing. Because when I call this client, I expect the exit code to be 0, so it's all success. But also I expect not to see this unpinned in my standard output. So let me like debug it now. This is the beauty of test containers. You can just go like into this bank and shout, "Everybody freeze!" Right? And it should freeze now. It froze, as you can see. And now I can closely take a look on what happened. And I can go for this result, and it says standard output. And I say, open it here, and I see, I check. And this is the stack trace. This is the result. It tells me something. And it says, oh, I called this unpinned, right? And now I then scroll. I just scroll, but it tells me, see, here is the monitors. So here is when I'm pinning the virtual thread. It told me so. Okay, here it is where you're misusing it, sir, or you dummy. Oh, yeah. And so all I have to do is just go for this greeting obtainer, line 29. Let's go there. Greeting obtainer, line 29. It's this line. Yeah, I'm making IO call because it's client.send and whatever, right? But as you can see, I'm doing it inside synchronized method. Right, so if you want to downgrade the performance of virtual threads, if you want to butcher them, this is what you have to do, okay? Or if you want to like use them properly, Okay, if you can't avoid synchronized, if it's there for a good reason, then I suggest you go for these reentrant logs and so on. Just avoid synchronized thingy, right? Okay, so now let me go and let's rebuild the whole thing, because I need to redo the jar, which I will put into this container. Okay, so I need to like refresh it. Okay, okay, it's done. Let me try to rerun it then, the test. We're running the test again, and let's see if the virtual threads are still pinned or not. Oh, very nice, very nice. It's already in the middle. Oh, come on, it's getting late. Okay. See, yeah, I have something, but let it pass. Continue. Console. Come on. Yeah, it passed. See. So now I'm not pinning virtual threads. So this is, if you just want to experiment with virtual threads in your application, and you're not sure if you're not going to pin them because you don't know the whole code base. Nobody does, right, these days. This is what you can do. You can just pack it, create this artifact, put it into test container, right? Create the whole like networks. You can also use wiremark or whatnot, just to have like real network something, right? And then you add this delay with Toxi proxy, and you will see. It's really that simple. If you're more into like mocking and stuff like this, and you can do that because sometimes I mean, maybe it's even better approach, provided you can do that. You can go for JFR unit. Okay, there is this lovely thing called where is it? JFR unit, right? And it allows you to assert on JFR events. Java Flight Recorder. So what I'm doing here is basically I have this JFR events test, and now instead of using Toxi proxy, right, what I'm doing here is just I'm creating a little server, and this little server doesn't even have a delay, but it just does a lot of computation. So this is what it slows it down, right? And this is the artificial delay in my like fake / mock / stub / whatever server, okay? And then the same story happens. As you can see, I have the client, I have the request and whatnot, and then because of this enable event, so I'm interested in virtual thread pinned JFA events, right? I just wait for this event, and then I assert there were none. Okay, so the virtual threads weren't pinned. So you can also check it this way without test containers, if you can like have some marks and so on, because it's also doable. So this is one way how we can batch virtual threads. If you want to read it, I also have an entry on my blog post. How many lights are here in this room? 4 or 5? Yeah. Okay. Some people know the joke. Very nice. Do you know this? Right. It's the dualism of the light. Right. When we look at them, or the other way. Doesn't really matter. Right. So they be like like a molecule or like a wave. So. We've been given this task, this lovely task. Your boss told you, oh yeah, you've been to this. We sponsored you. We gave you this a nice like a reimbursement. You went to this conference like Java 21 and whatnot. They were wearing this fancy t-shirts with Java logo. So you should know everything about Java, right? And virtual threads. So now you migrate this thing to Java 21 because it's gonna be faster, right? Yes, and then you go for this demo. Or for that project, and it's not, sorry, it's still here. I need to open it. Where is it? Come on, this thing. Okay, is it this? Yes, it is. It's this. So we have a task, okay? We have a task, and the task is doing something. It's not really relevant, and this is how we used to do that in Java 8 and onwards, right? So if we had to do something in parallel, we just went for I'm doing this in a yet another thread just to show you that it doesn't like conflict with my main thread. And what we have here, I have a range of integers from 0 to 100. I turn it into parallel stream, and then I'm going to handle a task like for each of these things. Handling a task takes 5 seconds. 5 seconds, okay? It's a really intensive task. It takes 5 seconds. And the thing is, if I have this thing, right? And this thing is going to run for 6 seconds. And every task takes 5 seconds. How many tasks will I complete within 6 seconds? 1, Come on, like, now it's your time to participate in the talk. Don't be shy. Come on, you've drank your coffee. How many tasks? Come on. Sorry? 4? 3? Okay, little hint. This is my CPU. I have 16 cores. Okay. Okay, I'm not bragging, I'm just giving you hints. So how many tasks will we complete? 32. Okay, let's see. Sorry, I ran the wrong thing. I'm supposed to run this thing. We don't have time. We have to, like, when I ask you a question, you have to answer rapidly. Come on. It's worse than job interview. Okay, so we started 32 and finished 16, and it kind of like makes sense, right? Because it took, because I have 16 cores, I will have like 16 threads in this fork join pool, or 15 plus this thread that's running it. So I'm able to start 16 threads. After 5 seconds, I completed these 16 threads, and then I'm starting another batch of 16 threads, and so the story goes. That's why we see 32 started and 16 completed. Okay, makes sense. So how can you double this? Of course, we can go like because they tell you to improve the overall efficiency and UX and whatnot, right? And what you can do is just of having this once, you can have it twice, right? So let's do exactly the same thing again. Only now I'm going to do that in a stream 2 thread. So how many tasks will I complete now within 6 seconds? 16. Okay, let's try. 3, 2, 1. 17. Haha, gotcha, right? So we improved the performance, but not that much factor. Okay, why 17? Because this single thread also adds, okay, so the fork join pool was exhausted by this thing, but this thing added its own thread, hence 17 threads, okay? Makes sense? I don't know, but this is how it works. Okay, yeah, so then you see it doesn't scale this way. Yeah, see, like yeah, okay, yeah. So then what you do, you naturally switch to virtual threads, right? Because they're so cool and so fancy. So we go for virtual thread, it goes like this. So from 100 to 200 for every task, we're going to start a virtual, like I'm not even using executor, I'm doing this like a savage, right? Creating this threads manually. Let's run it. Okay, question, how many tasks will I complete within 6 seconds? Okay, not much more. By not much more, like be more specific, please. 16. Okay. Let's see. Sorry? 20. Can I get it when I say 40? 40. Can I get it? 42. Okay, let's run it. Let's run it. Let's see. We're engineers, right? And so we can play with the code. No. And we're gonna get 3, 2, 1, 16. There you go. Get jealous. Yes. Yes, 16. So it didn't scale much better than streams. So what you can do now, like, okay, why didn't it work like this, right? So I can do the following. I can start debugging. If you don't know what happens, you say debug 1, debug 2, debug final, debug absolutely, ultimately, no more debug, and then the story continues after weekend, right? So instead of just doing something for 5 seconds, let's say we're gonna do it in like 5 chunks, 1 second each, and we're just going to put it like to debug it, right? So this report basically it says I'm going to have like a fine logger, okay? For this, so I need to enable this fine log level. This is using Java util logging, right? So how many threads or how many tasks will I complete right now? We had 16. Can I get any more? Can I get any less? Let's see. The answer is I can't give you a precise number because it changes. So we finished just 4. But we started 100. So it depends how you measure efficiency. If you measure just number of started tasks, it's nice, right? KPIs go up. But if you just measure the finished ones, the KPIs go down. Okay? Why is that? And you see, we didn't even see these fine log things. We don't see the darn logs, and the whole thing works totally different. So what the actual heck, right? So let me ask you this question. What happens here? I/O, exactly. And what do virtual threads do when I/O happens? They unmount the carrier thread. They get out from the taxi, and the taxi then, let's say you came here by taxi, okay? And then you call the taxi again. And they're super busy. Are you guaranteed to be picked up by taxi? Exactly. I mean, maybe Uber or some taxi corporations are doing this. Maybe they favor their gold or platinum or senator clients. I don't know. But in naive understanding, it doesn't happen, right? If you just came here by taxi and if you call taxi to go back, there's no guarantee they will do that, right? So you might see that you're waiting with, and you're just trying to get a taxi and they're just passing by, not picking you up, right? It's not New York when you go just a taxi, right? Which is absolute BS. Nobody does that in New York except for Hollywood movies. Yes, so this is the issue. We started looking at virtual threads. We introduced logging, and therefore we're looking at them, so they started to behave differently. Just by trying to observe the system, we altered the way the system behaves. Okay, so how to look or not look at virtual threads. Okay, let me go for this scratch. I have this little scratch thingy, so maybe we can do something different. Maybe I can go for this steps little map. Oh, it's already here. Very nice. How convenient. Then I'm going to copy this. So in the main method, we're going to print it this state of each task, and then we're gonna to say in this report thingy, where is this report method? Here I'm going to not only print it, but also put it into this map, okay? To get us like a little bit understanding what happened. Let's run it again. And 3, 2, 1. Okay, so we have. Okay, let's. I forgot one more thing. Let's here. Let's also add, so we know. Sorry, that wasn't me. Let's know it's finished. Finished. Right. Cool. Blum 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 blum. In 3, 2, 1. I didn't get the timing right. Sorry. Okay, so we see some finished, right? And we see that the 5 threads are finished, and we see here finished, finished, finished. So that was 3. Finished 4, and we see finished 5. Okay, that worked. Let's try another run. So it worked in that case, so we could proclaim great success. But let's see now in 3, 2, 1. So we see 1, 2, 3, 4, 5, 6, 7, 8, 9, 9. Right? Cool. It still works. Sometimes it doesn't. We just need to land in this thingy. Usually when this number is quite low, it's 4. Okay, it's the 4. Sometimes this number isn't equal. And why is this not equal? Here we see more than here. Because I still made the mistake of doing this before I get this, right? This is the right way to do this, this report. Else I don't know that's because still this logger might interfere, right? So let's run it again, and we shall see that it correctly, and it should tell us how the system actually behaves. Okay, so now as you can see, I have this finished 5 times, and this is what you see. It happens that so task 100 got lucky 5 times, but when it called for the last time, it didn't get the right, because this guy was driven for the very first time, for example, and so the story goes. So what we have to do now is, okay, we know it's the freaking IO, so we get rid of this, okay, and maybe just to land of the safe thing side of things, we even don't go for this, right? And now we go here, and let's see in 3, 2, 1, come on, 16, and now it sort of makes sense, right? So please remember this. It's I/O that unmounts virtual threads, right? And if we don't have now back pressure control, that's why it started 100 virtual threads, okay? Because it was swarmed with tasks to do, and instead of continuing the task already started, just like parallel streams do, it was eagerly picking among the whole pool of available tasks, okay? So Not in order not to butcher it, first we can't change the way it works just by observing it, but say it really has I/O inside. So what should I do then? You should go for back pressure control, right? Blocking queue or something. If you just ditch reactive thing and go for virtual threads, right? So reactive is about this async thing, but it's also about no side effects, and it's also about back pressure control, okay? It's not just a synchronous thing. Please remember this. Yes. Also, like another blog post entry, if you fancy, don't look at virtual threads or else. Structured concurrency. It's about having better idioms for multi-threaded code in Java. It helps us, or should help us, to eliminate thread leaks and cancellation delays. And for now, it's not replacing interruption with cancellation. And this is how it might look like. Okay, let me go for a code, okay? Because in code we trust. Code is usually better. Let's go here. Right. So you had this lovely case. You have to create embedded software for this digital scoreboard, like this LED display or something. So there are participants, and each participant has a name, and they have a score, current score. It's just there are two systems you have to call. You have to call name system to get user ID and the name, and you have to call score system to get score and user ID. Once you get this and this, you combine the results, all right, and then you can show them and display on this board. Sorry, I ran the wrong thing. And nobody is telling me this. I mean, how dare you people? Okay, and you see that Joe and Susan have 100 points and Krzysztof has 300 points, and it took more or less 2 seconds, and because initially we kind of like implemented it naively, so we called this thing, we waited for the result, then we called this thing, we waited for the result, and so the story goes. It takes 2 seconds, right? And of course you want to impress your manager, and the KPIs again the race, so we switch it to completable futures. And unlike me, which is just commenting thing out and in, right, you have to actually write it, but this is how it works. Like, so I have these executors. It doesn't have to be this virtual thread. It can be like a good old executor, right? We submit one task, another task, we wait for the result, and we combine the result. And my question is, if this thing takes a second, and this thing takes a second, how long the whole thing will take? A little bit more than a second. Sorry. It's on me. It's on me. Yes. Okay. Now, let's say, because it's network, it's always networks on DNS or cache or misnamed things. Okay. So it's actually one of these few things. Okay. Let's say an error happens, right? After 1 second, we just get a problem from the network. How long will it take before we know there is a problem? Or how long the whole thing will run now? Come on. 1 second. Let's see. Yes, 1 second. And let's say it doesn't happen here, but it happens here. How long will it take? 1 second. Ooh, yeah, shocked and surprised. Very nice. Yes, why does it take 1 second? It takes 1 second because of this. If this guy fails, it doesn't notify this guy, look, there's no point in waiting. We will need to sort of like subscribe this completable futures to each other. So when one fails, it tells the other guy, look, I failed miserably, like just finish your drink and go home, okay? Because there's no reason in doing this anymore, all right? It's just with 2 completable futures, it's sort of like doable. It's just one here, so we have 2 things. With 3, you have 6 interactions, okay? With 4, you have more interactions. I don't dare to count. Okay, that's why it's called callback hell. Okay, because it has to call back everyone, right? So therefore, we might have a structured concurrency. Now, a very nice thing. See, now instead of executor service, I have shutdown on failure structured task scope, and the idea is I can chop my task into smaller subtasks, okay? So I create one fork, I fork here, so I have 2 subtasks, and I then here join, so these things happen at the same time, like asynchronously, right? But here I switch back to like asynchronous thinking, and then I just get the result, and combine the results. And the whole idea is that it takes no time to figure it out if this guy broke instantly. Because we get this cancellation for free. Within this fork, and you have like fork inside the fork and so on, we can go deeper, right? Like Leo DiCaprio and so on. Then we know it, okay? And it stops instantly because it says shut down on failure, okay? but we can budget this. All right? What we can do instead in this oops, right? Instead of, yeah, okay, so we have these oopsies, right? And this, we have this sneaky sleep. So maybe instead of having like a sleep, see, it has this interrupted exception. Do you see this, right? We can maybe go for this hard work again that I was using in the example before, right? And let's run it before. Let's run it again, and it will give us 1 second again. Why? Because what I'm doing doesn't give a damn about being interrupted. So let me check if it should be interruptible or pay respect to being interrupted. Let me run it again, and here we have 0 time again. So the lesson is, if you want to have the cancellation benefits out of structured concurrency, be mindful about interruptions, okay? If you want to budget the thing, do exactly the opposite. Make sure the task is not interruptible, okay? This is how it works, right? So we get this free cancellation. We can also have this shutdown on success. So whenever we get just one successful return, meaning no exception, the whole thing can shut down. But the principle of being interrupted still applies. Don't forget about this join and join until, and that the subtasks should be interruptible, okay? Because if they are not interruptible, you just like you're canceling the whole benefits of cancellation. All right. Scope values, last thing in this block, they are in a way like this immutable thread locals. Does anyone in the room, and you don't have to raise their hand because you might be afraid it's recorded, just blink, okay? Does anyone had this lovely situation when you come back on Monday and you see this ticket that customer X of your banking system, insurance system, or any other system actually was revealed or shown the statements of the other client they don't know? Blink. Yeah, and chances are this is because we put the user ID of this original client, right, or customer into thread local. Then this thread got reused, and then because it was already there, we didn't like check what that user is, and we like fetch from the database or third-party system the statements from that first person instead of like going for this new person which got this thread accidentally reassigned. So the idea is that we have like immutable thread locals with bounded lifetime. So we see in code, it's from here to here. It doesn't require like sophisticated debug foo to figure it out after 2 weeks, okay? Because someone forgot to clear thread local. Therefore, we'll have simplified reasoning and improved performance, because if I have 1 million virtual threads, and each thread of these 1 million threads has its own copy in thread local, I have 1 million copies. Not so good from memory footprint perspective, right? So it's better to keep it just once if it's immutable and for every thread, okay? So thread local doesn't change, it's still the same because it does still valid use cases. And it works more or less like this. Do we have any Star Wars fans in the room? Very nice, because the demo will be about Star Trek. Yes, only after I find it. Yes, I have it. So there's this starship called Voyager, right? It got brought by aliens to the other side of galaxy, 70,000 light years away from home, right? And so this is the starship, and we got like a, let's say, HTTP request. So we have like a security clearance level from this request, and this, as you can see, works almost, or looks almost like a thread local, only its scope value. And I should have like a level or something. I just keep integer for the sake of simplicity, okay? So this is what I can do, and I'm doing some stuff on Voyager. And what's doing this stuff? Doing this stuff is basically I check what's my security clearance level, and I get like save default because it looks like an optional from a certain angle, and then I have this scope, right, again, and then I can turn lights on and off, and it doesn't require any even if I'm in prison, okay, I can turn the lights off and on, okay? This is not NKVD style prison, right? So we torture people with light, okay? We're not savages. I can locate crew members, but then I have to be a crew member myself, so clearance level at least 2. And I can also block bridge controls, but for doing this, I have to be at least a captain. magic values. Don't do that at home. Don't do that anywhere. It's just for the sake of the demo, okay? As you can see, I am setting the security clearance level to what I got from the request, right? I'm doing some stuff. Then somebody accused me of committing some crime, so I'm put in prison. Okay, so as you can see, we set the security clearance level for prisoners, which is 0, and then I run some stuff again, and then let's say, okay, these were false accusations, like you released from the prison, and we see what happens if we try again. Okay, so what happens is, okay, first I need to run this demo, not the other demo, and again, you didn't warn me how many people, come on. Yes, so, oh, this is not fortunate. One is not fortunate. One is not fortunate. Come on. This random thing is like giving me a hard time. Okay, 7's good. 7's good. Like the number of this room, lucky 7. Okay, yeah. So what happened? So we got security clearance level 7 from request. I can turn lights off and off. I don't have sufficient security level to block bridge. Okay, but I can ask the computer like locate commander Tuvok, and computer will tell me commander Tuvok is on deck 9. Then I'm put in prison in here, and I can't do anything beside turning lights on and off. Okay, and then you see I don't have to reset it like explicitly manually say back, like set this level again or something. It's just because I left this where scope, it's reset. It's brought back, okay? Therefore, I have security clearance level 7, only commander Tuvok, like move to deck 15, okay? Right, and then after I try to do something with this, after here, it's even like unbound, it's unspecified, okay? And it works very nice, as you can see, because I'm using integer, which has this nice property of being, what? Immutable. And I'll be a little bit cheating now, and because like we have time pressure, so let me, I don't know which shortcut that was. Let me check this out. Check out. Did it work? I clicked the wrong thing. Yeah. What did I click? I need to. Yeah, broken scope values. Yes, this thing. Let me see. Where were I? Scope values demo. Yes. So now I'm gonna have. I'm gonna have atomic integer, which is. It's even cooler because it's atomic warp drive and whatnot, right? Yes, it's just now the property of atomic integer is it can mutate, right? So if it's mutating now, we have this nasty villain, I guess, in here. See, even if it's still in prison, it says the security clearance level to 50. So it's mutating the whole thing, right? So when we try to run it now, we see strange things happening, okay? So this was supposed to be just a visitor. How convenient, I got like 1, okay? So it should be able to turn lights on and locate, and it should be even able to locate Commander Tuvok, right? Because 1 is not enough. I should have like at least 2, but see, it's able to locate Commander Tuvok. Come on. And here, you see, it's like security level 1, which like, okay, I should be in prison, so why is this happening? And then this shouldn't work, okay? And I shouldn't be able to block bridge controls. And here I like bridge controls, again, I block, and it's 50 and so on. So this is kind of like, it's not exactly log4shell situation, but by having this thing mutable, you sort of make yourself exposed to such issues, right? So the whole idea is, with scope values, that they work nicely with structured concurrency. You can call them at run or callable if this thing needs to return something. This work can be nested, Matryoshka doll style, right? But this works as long as you don't mutate the darn thing, right? So use something unmutable, unmodifiable in there, use a record, use a list that can be unmodified, something like this. Just don't rely on the contract, because I assure you, sooner or later, there will be a new member of the team who's just not aware of this, because how could they, right? How could they know? And they will mutate the darn thing, and you'll see this, we'll be back in the thread local situation where you'll have to blink, okay? So how can we batch virtual threads and friends around there? So use virtual threads mainly for CPU heavy tasks, okay? Not for I/O, use it for everything, okay? Swarm task without any flow control and without any back pressure. Ignore unmounting for I/O, Okay, just synchronize everything. That will be safe, like a vector was. Okay, pull, reuse, and mix virtual threads with synchronized. Ignore interruptions, and mutate scope values. This will guarantee that you'll have like secure job, because you will prove that everything that comes from Project Loom is just rubbish. Okay, and you can easily prove it. It's just rubbish. Don't use it. Like good old Java 7 is still the king. Yay. Yes. I have this, now I have a request for you, okay, for every conference talk, for every meetup, every gathering, just provide your feedback, okay? If there is a way, I don't know if there's a way, there should be a way for JFall to provide your feedback using like, they will send like a poll or something, or you can maybe use your cell phones. Please provide feedback. Let the organizers know how was it. Let me know how it was, because it was the very first time I gave this talk, okay? So I really love your feedback. Now, if you're watching this on YouTube, you should do two things. First, you should hit the subscribe button. Yeah. And second, please fill this survey, which is somewhere around here. I don't know, but click there. If you prefer this thing than conference thing, you can also fill this survey. But I would say you should prefer the conference thing. Okay. Be nice to the conference organizers. So that's the little survey. If you fancy more IT insights, Java hints, or pool life advices, follow me on social media. I'm Twitter, Mastodon, Blue Sky, LinkedIn, whatever. You can hire me for training, for some little consultancy or something like this. I do such stuff like how to not to butcher things when you're migrating stuff to new Java, right? If you need slides, this is the slides, okay? Just go with this link. In 3, 2, 1, because we're really after time. I'm terribly sorry, I overstretched this. See, I didn't do timing properly. That would be it. Thank you very much. Bedankt.